Hello and welcome back to Build Proportional Lab at Devoxx Friends 2024, day 3 here, coming to you live from Paris. And I have a new old guest here with me, Mark
Hello.
Rendle. Hey, Mark. And you might remember the great episode that we did with Mark about the biggest bugs or not mistakes.
Mistakes, yeah.
Mistakes in software history, and we declared that null was most definitely the one.
Yeah,
And now Mark is back for the second topic of conversation, and this is how do we prevent next JavaScript from happening to our industry?
Yeah, no. So I have a talk called "How JavaScript Happened,"
Yeah.
which kind of implies how do we stop it from happening again. It's a title to hang off a history of programming languages, but you can't do that in an hour. There's
Of course, there is
hundreds of them.
just so much. But JavaScript is fascinating because pretty much everybody agreed that there are terrible. Most of JavaScript is terrible,
Yes.
but also it's absolutely the backbone of our entire IT. All the internet runs on JavaScript.
It's terrifying. The thing that scared me the most was not just the internet running on JavaScript. The Crew Dragon capsule that SpaceX used to fly astronauts to and from the International Space Station. The user interface on that is, I think it's React. It's definitely JavaScript.
And what can possibly go wrong?
I know, right? It's like, oh no, we tried to switch from hooks to effects, and now we've lost 5 astronauts. It's just,
Jeez.
um,
This is what's fascinating about it. It's so bad and it's so entrenched that no one even. I wouldn't say no one even tries. Probably there are attempts to do something with it, but most of the industry just gave up.
yeah, most of them did. Microsoft invented TypeScript to try and fix some of the problems.
Which is nice,
And
but it doesn't.
does.
Yeah.
It fixes some of the problems for developers.
Yeah.
You can kind of go, all right, so this is expecting that type of object and so on. But it doesn't really fix the runtime issues. And then we have, Facebook with React and Google with Angular, and people kind of layering these libraries on top of it. And to be fair to JavaScript, since 2015, the TC39 committee at ECMA have been iterating on it and trying to improve it. And there's even the possibility of getting type hints like Python has had for a couple of versions now. But the main focus now seems to be WebAssembly.
Right. So, how does it relate? Will it help us solve JavaScript? And is there a path forward, basically?
I think so. So you can, if you've got some critical functionality, let's say you need to do finance, accounting things, which in JavaScript is a nightmare because of floating point numbers. And if you say 4.99 times 5 with floating point numbers, it comes out as 4.94444444449. But you could take a language that has a finance-friendly decimal type, like C# or Rust or something.
Or Java.
You could write your calculation code in that, compile it to WebAssembly, and then call into that from JavaScript. And so I think that's a big hope at the moment, is we'll be able to use WASM to fill the cracks in JavaScript.
How friendly is it? I guess for that to real catch up, it needs to be absolutely seamless, right?
Yes.
Because the trade-off is, should I just do something crappy that kind of works in JavaScript, or should I work really, really, really hard to get it right with WebAssembly, and it's a pain in the ass. And the benefits are, well, it's better, but you know what, JavaScript was fine.
Yeah, and I think what I predict we're going to see is people will start publishing WASM packages to NPM with a kind of clearly defined API, and then you go, I need decimals that work. I will just reference decimals that work from NPM, or graphics libraries, or game library, anything that JavaScript itself is not that good at.
Yeah, that will be definitely useful, right? Instead of calling stupid npm packages that do like what spaces,
Left pads,
and all this kind of stuff, we will have actually useful packages that not only solve a problem but also solve it correctly, not relying on the deficiencies of JavaScript.
Yeah, exactly.
Well, that's definitely will be a huge improvement.
And it will also mean that things like Webpack and the build tools that exist for things like React and everything. SAS is a very good example. There is a C or C++ implementation of SAS which is a lot faster than the old JavaScript version, and now we're getting to WASI, the WebAssembly System Interface, although standard interfaces they're trying to change it to. And that will mean that people can write these tools in Rust or Go or Java and compile it to WASM, and then we will get to a point where WASM is just natively executable on Mac OS and Linux and Windows, and we'll get the speed of native compiled languages, but completely cross-platform. It will be the same WebAssembly that you're downloading on all the different places, and I think that's going to make a big difference as well.
So yeah, no, that sounds hopeful.
Mm-hmm.
It does, and I guess, folks, for you who's watching, it's time to look at WebAssembly if you didn't already.
It really is. So version 0.2 of WASI, the system interface, which defines, if you want to talk to the file system, it gives you a component that talks to the file system. If you want to talk to the network, it gives you a component that talks to the network. And 0.2 is that the people are saying, or the people who are involved in it are saying, you can actually start to build stuff on this. It's going to be refinement and stabilization from now on. And we're already seeing Kubernetes is introducing, you don't need a Docker image, you don't need a containerd, an OCI image. You can just have a chunk of WASM and you will be able to run it in a Kubernetes cluster.
Wow, this is
serverless.
This is nice.
It's going to be. I think it's going to be huge. I think it's the next thing, and actually, I think in an interesting way, if JavaScript had been better,
then we
wouldn't have WASM. And I think WASM is going to be a game changer. And so, in a way, thank you, JavaScript, for being a little bit rubbish and not quite good enough, and forcing people to go, oh, there must be a better way.
I love it.
That's a nice way of looking at it, I think.
Yeah. And the last kind of actionable piece of advice, how do people get started with WASM?
It depends what your programming language is, but for most of the main ones, I'm a C# developer. I can compile to WASM, both using Blazor, which is the new .NET front end, but also just take some library code, and I can now compile that to WASM. You can do that if you're a Java programmer, a Go programmer, I think Python now. Basically all the languages that have any hope of remaining current are having to take WASM seriously as a target. So yeah, just look into where your language is and see what you can do.
This is cool. This is here, folks. Here's the future for you. And if you looked for the next big thing, that very well might be in it.
Yeah.
And it's definitely you should remain current and get up to speed with news about WASM. And this is what we do here in Build Proportion Lab.
Yes.
Thanks to Mark.
And can I just say,
Yes, please.
I've been here for 3 days, and you've been sat here in the corner. I've seen you talking to so many people, and your enthusiasm is just so infectious.
Thank you.
It's really, really great.
We try to make it fun. We try to make it fun for folks who's watching that. And Mark, thank you very much for coming.
Thank
and
you
with that, you stay tuned for more episodes of Build Proportion Lab. We have, I would say, at least 5 to 10 more today. It's a whole day, so don't miss more of those. We will be with you soon enough.